So today I'm going to talk to you about open source, an open source project called Cedar. Has anybody heard of it? Excellent, great, great. So only a few of you have heard of it, so you may learn something today from this talk. Thank you. Well, first of all, I probably should introduce myself. My name is Derek. I do work for a company called AWS, and we're going to talk about security and authorization. I've got 30 minutes, and hopefully I can get through it all. There's a lot of detail around authorization. I'll go through how to define the Cedar policy. I'll go into detail on how the engine works, and then we'll go into a demo. And hopefully by showing you how to write Cedar policies and to use the interpretation engine, then you'll go away and have a play. That's the outcome I want, is you go home or go now and play with Cedar. So we'll start with a bit of a level set. So what is authorization? So authorization, everybody uses it. If you're a developer, it can be very challenging. But in its very fundamental thing, it is determining what you can do, so what a user can do on a particular thing. So it's because it's a principle, it is an action, and it's a resource. So they are the three key elements of authorization, and they're all used to determine, can you do something in an application or can you not? And why is it hard? So I'm sure everybody who's tried to write some authorization code in their time has had some, challenges. Well, it's hard because there are a number of types of authorization for a start. There is role-based access control and attribute access control. There are others. There's a relationship access control as well. But for this talk, I'm just going to talk about RBAC and ABAC. And it's been known for a while what these are. These are not new concepts. They've been around for some time. However, they are incredibly hard to implement. So for example, role-based access control is based on the role you have in a group or groups, right? So you have to define a principal in one or many groups, and that group dictates what access they can have. So Derek might be in the writers group of a blog, but may also be in the admin group of a blog. And as applications grow, then Derek might pop up in another group and another group. And so you have to define and maintain Derek as he has access to many, many groups. What's the one? What is the principal access and resource that actually has precedence? So maintaining that's hard. Also, trying to do that with attribute-based access control is hard as well, because with attribute access control, Derek can have one or many attributes which define what he can do. So Derek may have the attribute of author. And so the attribute, as the application grows, Derek can get more and more and more attributes. And some of the attributes may be in conflict with each other as the application grows. And so again, hard to maintain, hard to author, and hard to audit. So who's written code like this? It's an if statement to check if a user has access. We've got some people who are being absolutely honest, and I respect you. Thank you very much. I have written code like this, either an if statement, switch statement to check if a particular user or a request has access to do different things. And it can get very, very messy very, very quickly. So in our infinite wisdom as developers, we've thought, well, let's abstract the isAuthorize call into its own thing. And so the code becomes a little bit easier to read as we're just delegating to this isAuthorize system. And then inside the authorize system, we define policies. So this is where we define what everybody can do. So you look, it's a principle, it's an action, and it's a resource. So this particular policy, and I can't read it, so I'll go over here. So this particular policy is going, for any principle, the action is check out, and the resource is the Hotel California. So that's saying I'll permit anybody to check out from the Hotel California. And the second principle is I will forbid, I should have looked up here in the first place, I will forbid anybody to leave, the action is leave, the resource is Hotel California. So that's how we define a policy that this authorization engine uses. Now, again, as developers in our infinite wisdom, we go, I can write an authorization system. That's flipping easy. Well, actually, it's not. Has anybody tried to build their own? Has anybody tried to build? Nice. Sweet. OK, so if you start building your own authorization engine, it is quite tricky for three main reasons. And these are the three I've picked out. First of all, you have to come up with a policy language. So you have to be able to declare who has the right principle, action, and resource, just like we see in Hotel California example. You need to be able to do that in an expressive manner, right? So you need to cover all eventualities inside this language. But you also need to make it easy to define. Otherwise, you'll end up with a policy language which is unreadable. The second problem is that authorization requests, they need to be quite quick because they happen a lot inside applications. When a user does a particular action on a particular resource, we want to know very, very quickly if they're allowed or if they're denied. And then finally, the last complexity of writing your own authorization engine is the fact that you need to validate and audit what's there. So when I give the example of Derek being across many groups, well, what is Derek's actual privileges if he's across many, many groups? So you need to audit that, flag errors, and validate them. Well, it's quite hard. So this is where Cedar fits in. So Cedar is open source, and it is three things. There's three core parts to Cedar, which nicely marry up to the complexities of writing an authorization engine. First of all, we have a policy language. So Cedar is a policy language, which is expressive, and I will go through the details of the policy language as part of this talk. Next, in the second part of Cedar, it is an authorization engine. So it evaluates the request based on a number of things, including the policy language. And I'll go into detail on that as well. And then finally, it's analyzable, which is a word I learned from my American colleagues. And it actually applies automated reasoning to analyze the policies, the entities in the application, and give you a valid, if it's valid or invalid. So I'll go through that as well. That automated reasoning, if you've done software engineering or computer science, is a whole topic in itself, and I'll touch on it a little bit and share some resources. So let's start with the first part of Cedar, which is the authorization language. So this is a typical flow for policy-based authorization. If you've used AWS, you'll be very familiar. This is IAM. This is how IAM, Identity and Access Management, works, where you get a request. Can you perform a task on an action on a resource? And then in IAM, there's policies defined as well. And then based on all of that information, it will return a result to going allow or deny. This has been done. So to work that out and to make sure you understand how that's defined, there are three parts to the Cedar policy statement. There's the effect, which is the action, not the action. It's the effect, is forbid or permit. There's the scope, which is the the scope of the three elements. So the three elements are principal, action, and resource. And the scope is, how, like, so Derek or group admins are the scope. So you can have one or many things against each of the principals, actions, and resources. And then finally, there are also conditions. So like anything, you can add clauses. So in Cedar, it's when or unless, and a few others as well. So this is what a Cedar policy document looks like. So there's two parts to the policy document. There is the head, which is the green bit, and the purple text is really hard to read. And the second bit is the condition, so that's the really hard to read purple text. And so the head deals with a typical role-based access control. So inside, you'll have your principal and your action and your resources, plus the scope of each. And then below, in the conditional, you'll have your attribute-based access control. And when you first see this, you go, why did the authors think of splitting this up into bits? Well, I can tell you the answer to that. So the authors inside, I think it was the Amazon Science Division, got some feedback from developers, and the overwhelming feedback was, we like the RBAC and ABAC concept, but we like you to split it up in 2 bits. And so the engineers, as they're building it, thought, yep, that makes sense because it's easier to read, right? So you can easily consume what that policy is saying. But also, you can evaluate it quicker because you can evaluate the conditions before evaluating the head. So called splitting. So it means that the result from the authorization engine is faster with using the policy definition like this in 2 parts. So there you go. So the first and most important part of the language is the effect. It's what's called the effect. And so the effect is 2 parts. It's the permit and the forbid. So this example here, I'm saying any user in the team admin, while performing the action delete on the resource tinyToDo is allowed. Whereas any principal in the team non-admin users, an action delete on the resource tinyToDo is forbidden. It's that simple. Is everybody following along? Does that make sense? Nods, nods, nods. Sweet. And a thumbs up. Go the thumbs up. OK, so that's next is the. Oh. So, OK. You would think I'd know how to use a clicker by now. So next is the scope. So the scope, as I said, is how much applies to each of those items, so principal, action, resource. So I describe that always very badly, so this is, by example, is the best way to do it. So the first example is a permit, and the permit's saying the principal in team admin, any action, so the scope is any. So if there's no scope at the end, just a comma, then it is all actions. And then on the resource tinyToDo, that's permitted. And then the second example, any principal. On the action delete task, on the resource tinyToDo is permitted. So that is the scope, the thing after the keyword. Now, all the examples I've given are examples. But in production and in the real world, you would define your principles, your actions, your resources, typically as UIDs, because you really don't want them to change. Like, for example, the example I gave earlier, the user in group admin. Just say that group admin changes name. So that's why you should always be using globally unique identifiers when you're defining your scope. So this one, again, I'm just reiterating so you understand. By repetition, you'll understand the language. So permitting principals in that team name, any action on that resource in that application. Second one, any principal, action, delete task in that application with that ID. Next is the second bit, which is, oh my goodness, that does not render well. So the conditional clauses, when. So if any conditional clause is false, then that is a deny, right? So it's basically an or. So when there's multiple, you can have one or many whens or conditional clauses. So that's saying when a resource has odor or when the context.ip.address is localhost. So that's how you define conditional clauses. And you can also group actions. So to make it easier, you can have multiple actions in a bracket, just like you define an array. And so that's any principal in all these actions, delete task, delete task, create task, list task on that application are permitted. Next are namespaces. So you're allowed namespaces inside the Cedar policy language. You use colons to define that. So again, in the tiny to-do team admin, any action in the tiny to-do application in the list object is permitted, and then any principal in the action delete task tiny to-do list is permitted. So that's the policy language. But obviously, the policy language is one aspect of authorization. You also need to understand the application and the entities that are in the application itself. And so Cedar allows you to do that. So as you're writing the application and defining the entities, so this graph is an example. So this is a photo app. So the entities are user, user group, photo, album, and the actions, which are also part of that map, are view photo, manage photo, and site admin. So that's, those are related to the application you're building, and Cedar can reference them, which makes it incredibly flexible. So in this schema, so on the right-hand side on green, I'm going permitting principal in team admin for the action delete task. And the action delete task actually comes from the application. So it's defined in a schema file, which you define as you're writing out the application with Cedar policies, and you put them side by side. So you have the policies. I'll show you in the demo as well. You have the policies in a schema.json defining your entities and actions. And that's how it knows about it. So Cedar will read that and know what each entity is. So that's the policies and the entity types of Cedar. The next bit, for me, is the cool bit. This is the authorization engine. So the authorization engine takes all of the inputs. So there's three inputs, really, usually. There's the policy, there's the entity data, and there's the application context. Because remember, for authorization, we're usually dealing with a request. So we need the context. They're all put into, squeaky, squeaky, squeaky. They're all put into the authorization engine, which has two parts. It has the authorizer and the evaluator, and that then returns allow or deny. Pretty simple. Now, one thing to note is with Cedar and the evaluator, it's a default deny, like most things these days, which is great. So policy match, if you match the Cedar policy, then it's a permit, and it returns an allow. But if there's no policy match, or it's explicit deny, i.e. forbid, or it's a policy match and an explicit deny, so that's a permit and a forbid, it will return a deny. So it always defaults to deny. Now, the complexities of authorization engines is, how do you know they're right? If you write an authorization engine or pull down an authorization engine from the internet, how do you know that what it's returning is correct, given its inputs? You're relying on it. It is dictating your security posture. So with Cedar, it's very, you have to, okay, so to answer this question, trusting an authorization engine, you have to think about, well, how do I build trust into the authorization engine that I'm building, okay? And so it needs to be easy to verify, right? So you need to be able to verify what you're getting is what you expect. But also it needs to be fast, because it's an authorization engine. Now, those two things don't really go together, because to verify something takes time. It takes a lot of time. So what the Cedar team came up with is having verification-guided development. What's that, Derek? Well, let me tell you. Has anybody used Daphne here? Anybody heard of Daphne? Daphne, thank you. So Daphne is how you define software to be correct. So it's a language where you define, say, a method as an example. So you define the method, you say this method must return, if it has two parameters, x and y, it says this, and a return z. You say that this method must return z, must be greater than or less than 3, or greater than less than x, one of the parameters. And so Daphne will make sure that all calls to that method are always correct. So that when you write another method that calls that method, that breaks the assumption, it won't compile. So it's a great way of writing software that will do exactly what you think it will, all right? Now, it's completely different unit tests. Forget about unit tests. Daphne is how you define it. So once you've defined the Cedar model in Daphne, you're saying, this is how I want Cedar to work in the Daphne language. Daphne's slow, okay, because it's verifying every possible permutation that can go through this application, through this model. You then have to write it in something fast. So the Cedar team wrote the Cedar application in Rust, super fast Rust. Everybody, all the cool kids are on Rust now. If you're not on the Rust, then you're not living. So on the Rust, wrote Cedar. And what we did is the output, so for request entities policies that we inputted into the Daphne implementation, we inserted the same into the Rust implementation, got the output, checked for equivalence. If it's yes, sweet. If it's not, bug, go again. And that's how we built up trust that the Rust implementation, which is what you use because it's fast, is actually equivalent to the model, the policy model that you want. And then we went another stage and built, when I say we, I didn't do it, they then used Cargo has a random input generator to fill the request to then check it even further. So that gives you confidence that Cedar, the authorization engine in Cedar, is doing exactly what you think it's doing with nothing untoward. Really interesting. I explained that really badly with the screen and everything and my words, but this is a great article. It's a really great read. If you want to go into more detail on how this was done, it's very cool. If you're a software nerd, you will love this. So yeah, please do it. Okay, so I'm going to run over time, everybody. So next is policy analysis. So you can also now analyze the policies. So make sure that they're right, and you can audit them and check for equivalence. And you do this using the Cedar CLI. And so this is an example of the Cedar CLI. Once you start using Cedar, you can use the CLI, and that's how you do it. Okay, demo. Source code for the demo is here. It's on GitHub. It's written by my very good friend and colleague, Ricardo, who's in London, and it is here. I'm glad I recorded this. This demo is 7 minutes. So what it is a app that has photo sharing, so it's got some permissions. Anyone logged in can view public photos. Only members of the Doe family can access private photos. Any member of the photo admin group can perform actions on photos, and only members of the site admin have admin access. Here's the model. I'll go through that, but this gives you a better idea. So John and Jane are the Does, so they have photo admin. Admin has site admin, along with this dodgy Deza character, who also has public, along with Joe Public. And this is how it works. Request comes through as a Flask app. So then you go use the Cedar definitions along with the authorization engine that asks the model, which is schema.json, and entities.json, which I'll show you, whether you're authorized or not to perform the task. This is the code. I hope you can see it. So what? Oh, no. Why? Things are going really badly. OK, there we go. So it is a recording. I apologize. So this is the Flask app itself, app.py. It's written in Python. It's got entities.json. So this is the entity. So it'll have all of the entities and entity types that you have in your application. So John Doe, Jane Doe, Dodgy Deza, they'll all be there. Also, you'll have flask.cedar. So this is the policy definitions. So you'll see principal, action, resource. And then you'll have the schema. So this is what you define about your entity types and the actions that you can do on them. So we've got user, which is also part of a group. And then we've got photos, which is also part of an admin. So we've defined that in JSON. We also have actions that you can define on those resources. OK. So we've got, and the principles that it can apply to. So manage photo and site admin user photo. Here's the users. So most of these files are local. They should not be, right? So in a real application, these will not be local. I recorded this yesterday. So let's log in and use the application. First of all, public photos. So my photos, manage photos. So my photos is the private photos. Manage photos makes sense. And the admin page is the admin page. So go into public photos. And then the first person we'll log into is Joe Public. So Joe Public, if we log in as Joe Public and see what access they have. Welcome, Joe Public. Yep, logged in. So Joe Public, any logged in user can see public photos. So there's Joe Public looking at public photos, but nothing else can they see. They don't have that privilege. And why not? So if we go back into the policy language, we see that principal, action, resource. So we have principal, which is public user group. So if we look at our schema, not our schema, our entities, we'll see Joe Public is a user who's also a member of the user group public, right? So that's where it gets that from. Next, it goes view photo. So that's the action. So this time we go into our schema and look at actions. View photo action applies to any user. So that's how it satisfies that part. And then finally, the resource. So Doe public photos. That's in our entities. We find Joe public photos. It's an album. And that's where the resource is defined. So that then passes allowed when it goes through the authorization engine. And that's how Joe Public is defined. Next example. Next example is logging out of Joe Public. Joe's gone. We now need to see the Jane Doe's private album. So we log in as Jane Doe, who is one of the Does, if you remember. Jane Doe, logging in. And then Jane Doe, any logged in user can see public. My photos, which is private Doe's photos, Jane Doe can see them. And there's two handsome devils there that she really, really likes. Sorry. I'm having a bad day. And can't do manage photos because they don't have that permission. Why not? Well, let's look inside the policy document. And we'll see that user group Doe family, again, back to the entities, we'll look up Doe family. Doe family, there's two people in Doe family, Jane and John Doe, and that's where that comes from. Boom, who are users. Next, we are going for the view photo action. So what you go back and Doe photos is the resource. So that's me saying to me that any person in the DO family has the view photo action, but doesn't have the manage photo action. So to add the manage photo action into a member of the DO family, we change this policy. So we simply add the action manage photo